Hi, I'm Dave Robinson, and welcome to another one of my screencasts where I'll be using R and RStudio to analyze data I've never seen before. As usual, the data comes from the Tidy Tuesday project, an amazing project run by the R for Data Science online community. Also, as usual, I'm going to be working. I'm working live, and if you're one of the many people joining this session in chat, welcome. A big part of what makes this fun is having you join in, give ideas, give suggestions, ask questions about what kinds of aspects of this data you're most interested in. So I'm assuming people can hopefully hear me now. I see you live, and I'm going to go ahead and go to this week's data set, which is on coffee ratings. Coffee ratings. Now, I can tell you about myself. I am a coffee. If you know the difference between a gourmet and a gourmand, a gourmet is someone who likes who has very good taste and likes very good food or drink. Gourmand is someone who just likes food or drink. By that standard, I would say I'm a coffee gourmand in that I really like coffee. I drink a lot of it. I wouldn't say I have particularly good taste. I wouldn't say I'm certainly not an expert in coffee. So I think there's things that I can learn that's somewhat interesting in these from this coffee data set. Really something, and oh wow, quite a few columns we're going to be looking at in terms of coffee ratings. All right, so let's go ahead into RStudio, create a new RMD. I always start with the library tidy Tuesday R, or the library tidyverse. And let's load up the Tidy Tuesday data set, so it's TT load. I wonder if I can just can I just give it today's date and then it loads it? Yes, it can. That works because today happens to be, it's not reproducible. I will instead say July 7th. So, let's find out what, oh, somebody reminded me. Thank you, the Food Eater, for reminding me. Theme set, theme light. One of my favorite things to do with these data sets. All right, so, this comes from BuzzFeed data scientist James Ledo. And, all right, so it's been published on Kaggle. And here's our, today there's one data set, so I'm going to call it, say, coffee ratings.csv and pull out coffee ratings. And we're going to view it. Last week we had so many data sets, but this week just one. All right, so what we have is, we have species. There's points, which I'm going to leave this in. Trying to zoom out a little bit. Total rated in points. There's species Arabica robusta. There's an owner, which looks like it's been cleaned, made lowercase. Country of origin, a farm name, a lot number, mill. There's some missing data in some of these. I wonder how much missing data there is in each of them. There's altitude, but something that looks fun about this is that altitude is going to be in some possibly different units. What does this say, altitude? This is a messy column. I left it for some cleaning. That's cool. We could probably get some sense of. I'm hoping that it's mostly meters, because if it's anything but meters, it's going to be tough. There's region, which is also messy. It looks like a messy column. Could be a lot of things. Producer. All right. Now we have number of bags. How many bags were tested? So this is like a test. I'm just reading through this quickly. Some things we learned. Okay, so wow, they tested this many bags. That's crazy stuff. More and more information. What year was harvested? We could look at changes over time. What data was graded on, and let's see, lots of things. Who owns the beans? The variety of the beans, several types of beans. The processing method, whether it's washed, wet, or natural, dry. Here's the most interesting, not interesting, but here's probably the focus we're going to be looking at, is everything from aroma through moisture. Looks like it's different metrics we can use to, mostly from between 0 and 1, but let's check moisture. Moisture grade, sorry, I meant to say 0 and 10. Is the cup clean? Sure, that's a good expression. Moisture, category 1, Category 1 defects. Ooh, sounds dramatic. I don't know what Quakers means. Quakers are coffee cherries hold and underripe coffee bean. Oh, I see. Okay. So I guess they inspected it, and that's a defect in a roast. Is the number of queries. Okay. Category 2 defects. Hopefully not. Category 2 is less serious. There's so many things, and all the things about how it's certified. Some things. Okay. We have a unit of measurements for the altitude. Ooh, so there's some clean things in terms of the altitude low, altitude high. That's cool. So there was some cleaning. Okay, great. So we can do some things with coffee altitude. So many things to work with here. Who's excited? Everybody excited? I'm pretty excited. So let's get started. The first one is that I'm going to start by looking at just, let's see, I'm going to select, let's see, I always want the cut points. Species is nice. Owner, and what should I do? The company? No, what among these is unique? I really wonder that. Some of them are missing. Is there like a coffee ID? Do we see it? I don't see it. But ICO number, might that be the ID? Nope, not at all. All right. Partner harvest here, bad word. Oh, so many things to learn about here. And all right, I'm going to go ahead and say coffee ID. Somebody reminded me, thank you, Dave Assinger, to save the file, coffee ratings.rb. All right. And row number, file name, country. These are some things. Oh, there's no country. There is region, but there isn't country. Something in country. There's, what is it? In country. In country partner. That's not going to help. That's not going to help at all. All right, I'm going to just grab these and then importantly the aroma. Here's what I'm going to start with. I'm going to focus a lot on aroma through moisture because these are quantitative columns. I'm going to keep also coffee ID. Remember, the coffee ID is not anything global, just something I added. Why did I add it? Because I might, somebody told me that it is living life on the margin, told me, look at country of origin. Look at how many eyes I have working from here. Fantastic. All right, but before I actually do any kind of like reshaping of data, let's do a little bit of counting. Let's count species. Somebody reminded me of variety. I'm getting a lot of really good help here, especially possibly for people who know more coffee than I do. Vast majority Arabica. Okay, so species is not going to give us all that much information. Let's look at species and variety together. And I forgot to sort. All right, this variety looks like it might be one of the more interesting ones. So I might filter out, I might say filter not, and Robusta, yeah, I'm not going to use Robusta because it doesn't seem to have a variety. And it's not all that common. What if I say FCT lump? What if I say filter not is in a variety and FCT lump variety 10. 10 varieties. That could be pretty interesting. All right, and then how would I visualize that? I wonder if I went, well, I could count it and get a bar plot. But I'd like to do something else. What if I said mutate variety is this, and look at how does variety affect the score, the total cup points. So one thing we see is there is a, what do you call it, an outlier here, one total cup points of 0. So I'm actually going to say total cup points greater than, I don't know, 10. Try and get rid of that. It's a little bit better now. Now there's probably still a lot of skew here. So one thing I can do is if I wanted to say, here, I'm going to call this coffee lumped. Ugh, lumpy coffee. Sounds terrible. See, here I am making dad jokes. What I'm going to do is say coffee lumped and histogram That won't work. This is not, actually this works kind of okay, but better would be facet wrap by variety. And don't show a legend. And while I'm at it, I might do to lump. There's this many and other. I don't. So yeah, I just wanted to get a sense of, is this scale equals. Thomas Mach has a great idea. Think of GG ridges. Ridges are pretty good here. We can create a ridge plot. But I'm going to, let me see, I'm going to scale free. I still kind of like the histogram scale free, and we'll say bin width equals 5 in the histogram. Way too wide. This isn't too bad. There are a couple other ways we could do this, but the general idea is I wanted to ask: are the distribution of total cut points something like a bell curve within each? Very important. I need to scale free y, but not free x. Really important. Yeah, so one thing this kind of indicates is that they're not that far from normal. I just want to take a quick look at that before we. You don't really want to look at a box plot if your data is very far from normal, but if it is, then it kind of makes it comparable. And I can say variety is FCP reorder variety based on total cut points. So now I can say Typica probably the lowest. SL28 as variety? Yes, good old SL28. Who doesn't love the sweet smell of SL28 in the morning is the highest in terms of the typical the range. We do see there's like outliers. Katoi has some very low values. All right, but this is now we're getting like a feel for what some of the distribution, what some of the differences are here. Okay, so that was an examination where we just looked at variety. That's a very important one. But I'm going to look at a couple of other things. I'm going to look at count, let's see, producer, mostly missing. And that makes me wonder, a nice trick, you might have seen me use this recently, is say across what? Across everything? Well, why not? Across everything, get them, let's see, let me remind myself. Oh, right, yes. So what I can do is say across everything, calculate the mean that are not missing. Something I like to do with this is gather and view. What does gather and view do? It lets me sort it. It says, we have complete data for all of these columns. What don't we have complete data for? Here it is. And yes, so like lot number, we usually don't have data. Farm name, mill, producer, we often don't have data. Altitude, we're definitely going to do something with the altitude, but we don't. But it's worth noting we have data on 82%. Okay, this is not a very high missingness data set. It might be like a high sparsity data set. There might be a lot of messy data in here, but there's not a ton of missingness. So yes, there are 231 missing producers, and that is the most common, but it also, but there's also like a wide range of actual producers. So now I can say company. Yeah, so a lot of, a bunch of companies. I'm probably not going to do, am I going to do much with company? If I did much with company, I'd want to say what are the best companies, what are the worst companies. I probably want to look at the distribution within each company, the way that I do with variety. Variety is still going to be a little bit more interesting to me, but yeah, this is me trying to like get a feel for what kinds of questions we might be interested in. Probably company rather than producer. Let's see what else we got. Mill is we saw is missing a lot. Not that much, missing a quarter. I'm probably not going to do it. I think I could look at color. I'm going to take a look at processing method. Cool, there's 4 colors. Green, coffee. Okay, so I kind of thought coffee was mostly brown, and now, and like I said, I'm learning a lot. It is either green, blue-green, or none. So I pointed out we might be interested in country. Thank you, Dave, country of origin. I know, I really like this. We really can see like Mexico, Colombia, Guatemala, Brazil, Taiwan. Interesting to me that United States, does this mean all coffee from the US comes from Hawaii? That doesn't sound right to me. But all right, we're, yeah, this is actually, I think, kind of worth its own graph, as I can say country is FCP lump. So yes, so viewer shares that the color comes from unroasted beans, which, okay, that does make sense. And if I say count our top 12 countries and other, filter not is in a country, and get that backwards for that great rotated ggplot. Geom call mutate country is FCP reorder country by n. And yeah, what we see is, okay, this could be an interesting column, quality by country. And that actually tells me I'm going to try the same box plot I did earlier, but I'm going to do it by country. And I'm going to say coffee ratings country is lumped, reorder, oops, and never forget, actually I'm going to do this way early on, I'm going to say filter total cup points greater than 0, I can probably even say it, we'll get it out of the way, and clean this up. I want to get rid of that outlier, that's 0. I'm not going to miss it. Great. Okay, so what we see then is Ethiopia makes the best coffee. I think I've heard that. Mexico, just on average, the lowest quality. Places like Hawaii, Thailand, Guatemala, somewhere in the middle. And here's our other that kind of helps confirm, okay, this is the middle range. This typical median might be 80. Ethiopia is, yeah, generally higher quality coffee. That's all right. All really cool. I'm going to add in one. Not is in a country in here, and of origin. Ta-da! And great. Now we learn splits. All right. One thing I learned from Thomas Mock, one of the hosts of the Tidy Tuesday datasets, is that Hawaii, Puerto Rico, and California can technically grow coffee. Hawaii is by far the most common location in the U.S. That's really helpful. So that's one thing we can see here. It looks like Hawaiian coffee is about middle of the road mostly here. All right. So I've taken a look at country. I've taken a look at quality. I'm going to be returning to interesting dimensions. I think country and variety are the two that I've been the most interested in so far. I'm going to throw in company with question marks. It's very sparse. We just, compared to country, I didn't spend much time on it. And I haven't heard of the companies, so it's not going to be interesting, perhaps, the way the country is. But, yeah, I'm just going to keep track of these. Now, why am I doing this? Because I'm going to move on to, here we are, country of origin. I'm going to drop species, because it's mostly just one species. I'm going to drop owner, I'm going to do company, I'm going to drop farm name, company, variety, country of origin. All right. And then all of our columns. Now, why did I keep these? Because what I want to do is pivot them. I'm looking at all these metrics, aroma all the way through to moisture. What is cupper points? Can I look back at the help page? Nope, not help. It's coffee. Trouble is I don't have. I don't have this. I need to keep this object. Here we go. What was the copper points? Sure. Presumably it's something, maybe it's related to the overall score? Huh, I'm not sure. All right. Well, we're going to find out a little bit about it because we're going to look across all of these metrics. When we see these in all these different columns, well, our temptation first is to visualize some of these against each other. So I might say something like, I'm really curious, do we just add up all of these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then maybe they add up to the total cup points? And then if so, what am I missing? Am I missing moisture or what? I'm remembering, can I add across? No. But I do know the way that I'll be doing that. So what I'll be doing is I'll say pivot longer. What I'm going to say is I'll pivot the columns aroma through moisture and say the names that it's going to end up is metric. The values to is value. Because I just want aroma is this, the flavor is this, aftertaste is this, and so on. And if I group by the coffee ID and the total cup points just to keep them, and I say total is some value, it is not going to line up 1 to 1 because I think I accidentally left in moisture, and I don't think moisture is one of the values. I can change this to cover points. Okay, yeah, now notice how these line up exactly. All right, that was me double checking an assumption that I had, which is, watch this, if I do geom point, I bet you add up these 10 columns, look at that. Very close, except for I don't know what this is. Could it be a bug, it could be a data entry bug, could be a lot of things, it's not important. The general idea is they line up perfectly. So what I'm really looking at in total cup points is the aggregation of all of these values. Now something I'm curious about then, yeah, there's a lot that I'm going to be curious. I think I'm going to be doing dimensionality reduction. I think I'm going to be interested in what are the correlations among these values and how might they get across like different sources of coffee quality. I'm also going to be looking at how they vary by some of these dimensions. So what I'm going to do, but I'm going to do all that after I've pivoted it and I've dropped the moisture. Yeah, I still have moisture, but I'm not keeping it as one of the values. And I'm going to call this coffee metrics. I'm also going to add coffee ID way back when. I'm going to add that here. That way I just have it anytime I want to join with it. Coffee ratings, here it is. Coffee metrics, and now I can find out things about them. I'll tell you something I'm really curious about. What are the sources of variation? For example, one thing I noticed just glancing through the coffee ratings is that the clean cup rating seems to be 10 a lot. Uniformity is 10. Sweetness is often 10. Maybe it's sorted in some way, but let me try just sorting through the middle. Yeah, a lot of these are kind of centered around 10. So one thing I'm going to do is I'm going to start by graphing our values by our metrics. And I'm going to say geom histogram. And yes, Thomas is right, I could use, heck, I'm going to do it. I'm going to do a GG ridges. And I'm going to say geom ridge line. I think it's color equals metric. Oh, is it ridge line or ridge? It's actually been a while since I did GG ridges. Geom density ridges. Thank you. Yes. So Thomas got me covered after that. Geom density ridges requires. That doesn't feel right. Let's check on that. Oh, I get it. Y is the metric. Here we go. Hey, that looks pretty neat. Look at that. Some people used to call this a joy plot, which is a reference to, I think, a record. Things like a record cover. But here we go. It's a FCT reorder metric by value. Yeah, this really gets across to us that uniformity, sweetness, and clean cup are kind of the gimmies. You can lose points, but mostly everybody has a 10 on all three of them. Some people lose points. And what that is going to confirm to us is that if I take my coffee metrics, group by metric, and summarize the average is mean of value, and the standard deviations is the standard deviation of the value, what I'm going to see is arranged by descending average. Yeah, what I'm going to see is that sweetness, clean cup, and uniformity, what's actually interesting is their average is high, but their standard deviation is higher as well, which means they're a larger source of variation. I actually didn't expect that. I guess it's because these rare values, like clean cup, must have some values that kind of stay out here and then kind of give it a larger standard deviation. Oh, so they do determine something about, they do like tell you a little something about the, they do add variation, but it's mostly, it's like most people are right at 100 and then you go down from there. All right, yes. So, one thing I just learned is that from Lewis Maiden is that it's joy is joy, division, unknown pleasures. I don't know if this is useful to people, but I really like to check this out. The joy plot is a reference to that these graphs often look kind of like this. But we don't call it that anymore, we call it a rich plot. All right, so here we have the, here we have a rich plot of, I really like this rich plot now that I'm looking at it. Here we have like bimetric. All right, let's keep looking. Next thing I wonder is, do these correlate? I bet they correlate a little bit. There is actually a package, library YDR. My YDR package finds correlations among tidy data. We could also have turned to a matrix, do correlations there, but this lets us do pairwise core of let me remember myself. Yes, correlations among metrics based on coffee ID by value. There is a function that needs to be improved because of our dplyr 1.0.0. So what we see then is that aftertaste and flavor are highly correlated, as are acidity and flavor, and so on. So we can actually view this. We've used YDR's pairwise core a lot in these sessions, and one thing we see is that aroma and sweetness are not correlated, as a different example. So it kind of looks like there are clusters here, aftertaste and flavor. Do we see sweetness? We see aroma and flavor, then I'm guessing that flavor and sweetness are also not going to be correlated. So like one way we can there's a few ways we can visualize this. One is we just ask questions about what is and isn't. So nothing is negatively correlated, but it's kind of remarkable that there are metrics within here like sweetness and flavor that are not correlated at all. So the one way we can do this is take our correlations. Take the top, notice they go both directions, so if I take the top 40, I'm really getting just 20 connections, and put it into a network plot. You've seen me do this a lot before if you've watched these screencasts. What I like to do is I like to show clusters of these these metrics, because that's what I was trying to do just by looking at it manually. What I can do is say graph from data frame, gggraph, geom node point, for that a geom edge link, AAS edge alpha equals correlation, I think that's right, and then geom node text, label is name, and repel equals trope. So yeah, this is actually not helping us, it's showing us that all of these are clustered. I wonder if I do, but it's not showing us things that aren't clustered. All right. Yeah, this is a bit farther along. Notice here that it doesn't pop up into like perfectly clean clusters. Rather, it shows that this tight cluster of 1, 2, 3, 4, 5, 6, 7, and then sort of this other cluster of uniformity, sweetness, and clean cup. Looking back at my joy plot, were those the three that were, yes, those were the three that were close to 1. That kind of makes sense as to why those are maybe differently correlated. So this gives us like a sense of, yeah, there are two different types. I have a suspicion then, we're going to apply PCA, and I have a suspicion we're going to see something very similar. All right, remind myself a moment. How am I going to go about doing the PCA? So I'm going to be applying PCA to this. And there actually is a function, widely SVD. It's very similar to finding correlations. The difference is that it just takes metric, coffee ID, and value. The difference is that it actually returns metric by dimension. So this is doing something on our data set where we actually are getting like, what is the first dimension, what's the second dimension, what's the third dimension. I've done this a lot recently. I always find I forget exactly how to normalize. I never remember when I'm under pressure whether I'm supposed to center the metrics or scale the metrics. So I'm going to actually just try, this is a singular value decomposition, find the biggest sources of variation in these metrics. I'm going to filter for dimension is less than 4 and look at our largest sources of variation. And then I say metric, nope, value by metric, geom call, and I'm going to mutate, I'm going to use tidy text order within, reorder within. So I'm going to say metric equals reorder within metric by dimension, by value within dimensions. You've seen me make this, I make this graph a lot. It's me trying to say, and facet wrap by dimension, so equal to 4. Scale y reordered, and scales equals free. Okay. Yeah, the problem with this is that the first dimension ends up, I didn't center the values. Let me try centering the values, and I think it might actually work. How do I center them? What I do is I would group by metric. This is capturing mostly the fact that uniformity, screen cup, and sweetness are higher than everything else, capturing the means without getting anything interesting. So I'm going to say centered equals value minus mean of value. Then the average will always be 0, and I'm going to use centered in our SVD, our value, singular value decomposition. And would you look at me? I forgot to say scales equals free y. Here, yes. Okay, yes. So these are the sources of variation. One is that, just in that even centered, I don't really understand what this is, the clean cup, couple points. I don't have a good like feel on what this first dimension represents. I always find myself a little confused when I ask SVG results. So what we also see here is that the second principal component is everything in one direction except for uniformity, sweetness, clean cup, which I've learned from Chris Wu is evaluated differently on the cup score form. I also see then that within that, sweetness, so once we've explained this variation, sweetness and clean cup gets separated, and clean cup and uniformity gets separated. So the clean cup, sweetness, and uniformity. So these three are a little bit different, but it looks like there's just so much correlation. And this kind of confirms what we saw in our earlier network plot. So like this actually gives a very similar kind of, to me, like this actually gives a similar insight. I can probably bring down the number of correlations. I kind of like this one. Check this one out. You kind of have the experiment with the sensitivity correlations. It looks like everything is correlated. And then sweetness, clean cup, uniformity. More clean cup with these two, but also uniformity and sweetness are correlated. And then there's a light link between clean cup and flavor, but nothing else. That this kind of does get across. I think we can do PCA or we can do this. They end up giving, I kind of like this result. This shows that, yeah, there's like flavor, acidity, body, everything. If I want to do PCA again, what I would do is actually filter for not metric in sweetness, clean cup, uniformity, because I want to look at what are the difference between that and I bet there's so little correlation though. So little variation. I'm going to remind myself quickly, what are the correlations we're looking at here? Yeah, there's like 0.74 correlations. Okay, so the idea is like, I still don't understand the first dimension. It's always a little confusing me. I can't remember whether we center, which thing we center. But body versus cover points, balance versus aroma, aroma versus acidity. Those look to me like potentially dimensions that we can break down. So this is those ways we can say, okay, body versus copper points, balance versus aroma, aroma versus acidity. Again, I don't know what to do with this one. In fact, I'm I'm going to cheat a tiny bit and say filter. I'm going to drop the centered. I'm just going to do it. What if I did it on the uncentered data? I feel like this gets it out of the way. Like I said, I never claim to be a role model here. What I'd say is say filter dimension is between 2 and 4. And make it 2 and 5. One thing I don't see here, so this is like, what are the breakdown? What are so everything is a little correlated. We can say body and cover points, aroma and balance, acidity versus aroma, and body versus balance. I'd say especially, I don't know, the acidity and aroma, that feels like some clean ones. All right, so those are some ways we can break down the dimensionality. All right, that is one thing we've tried. All right, what else can we do here? Well, one thing I'm going to do is, remember how I got these copy metrics out? What if I threw in altitude mean meters? If I keep that in this, then I do my my copy metrics. I still keep this wide. I've got a question. Which of these dimensions, we've got these dimensions, remember, of like a body, aftertaste, flavor, balance. We've got all these dimensions that are evaluated in, actually, I'm going to quickly say, I think we've spent too long discussing this without actually looking at a cup score form. That's actually, I think, a mistake. Aha, you can see how they're evaluated. Clean cup, sweetness, acidity, mouthfeel, flavor, aftertaste, balance, overall. I think overall represents a cupper score, which I notice, interesting to see that is a little bit separate from body, maybe strong body, maybe their overall doesn't associate with a good overall score, or at least less than other ones do. Okay, but the sample, yeah, so this was me just trying to like take a quick look in. If you look at things like deviation, like defects, but what am I asking here? I'm curious which of these might associate with something like altitude and which might not. That's kind of a question that's popped up for me. So something I like about this. Let's take a look at our altitude. Altitude mean meters as a histogram. I really do wonder. All right, so there are some outliers. I'm going to go ahead and say that the altitude mean that these are parsing errors. I do not think that any coffee is being brewed more than 100 kilometers off the Earth's surface. How high could it be? I don't know. 10K feels like a lot. All right, so one thing I notice here is within this range, it kind of looks like, within this range, it looks like somewhat normal. Then we sort of have a long tail. If I increase it to even, yeah, then we have a couple other things. So, I like the norm. I like the roughly normal, typically around 1,000, because there's a lot of things we can apply we can do with the normal. So what I'm going to do, first thing I'm going to do is say, take our coffee metrics and filter for altitude mean meters is greater than 3,000. Let's say 2,000. I'm going to do it on our original data set. I'm going to select the altitude mean meters and as well as the altitude. I'm going to look at it. I can compare it to the rough data. Okay, these look pretty good. This is these are examples of bugs. It's missing a point in these. Unless it seems unrealistic, would say no. I take that back. This is, I think, 2.080. It's not. This is not a bug. Rather, I think this is range by altitude meters. This is the fact that in Europe, and I think in many other countries, you use dot to represent a comma. So these look. I mean, these don't look like they were misparsed. This is misparsed. This 3850 is 1800, 5900. That's misparsed. These just have no idea what to do with these giant values. So I'm going to go ahead and these look plausible. I wonder if I say country. Of origin. Many of them are Myanmar, Indonesia. Is it plausible? It's plausible. I'm going to say less than, like, I don't know, 3,000. What I'm going to do is I'm going to say mutate altitude mean meters is P min of altitude mean meters in 3,000. I'm cheating a little bit here. I should drop these out. Heck, I'm gonna, yeah, and I'll say like, okay, if you're higher than this, you just get stopped at 3,000. Yeah, I'm just doing that. It's a little bit cheating, but notice, yeah, it's mostly kind of work out these sizes. Now, why am I doing this? I'm doing this because I might be interested in the correlation between quality and altitude. In fact, I'm going to do it originally in our coffee ratings. I'm going to plot our altitude mean meters by by total cut points. So it looks like there may be a correlation. It's weak. It's a low R squared, a low amount of variation explained. But it does look like there is higher altitudes do have higher cut points. Okay, so and then I'm going to be interested in like, what is that correlation within each of our sources? Could it be that there's a strong trend within aroma and there's a weaker trend within body, for example? So we're gonna be taking a look at that within our coffee metrics. We do the same cleaning with this. We're gonna do the same cleaning on coffee metrics. And I'll say, what is the correlation between altitude mean meters and our value? You know, it's interesting. I actually really do see there seems to be trends here. The big one is that sweetness, clean cup, uniformity. Those are the three that are kind of separated. Those don't have, let's see, those don't have high correlations, especially sweetness has no correlation in this metric. But even yeah, the difference between you're like, it's so interesting. It's like everything that's not cupboard points kind of have like that's kind of the overall score. Everything that's not that has a stronger correlation, especially acidity. There seems to be a positive correlation between the acidity, like the score of the acidity and the altitude. Somebody suggested that coffee that we might have a bug in our let's see, in the zeros as well. If I said altitude mean meters, altitude filter, because coffee is generally not grown at sea level. Yeah, it looks like I have a lot of ones. 1, 1, 1, 1, 1, 1. -1, 1, 1, 1, 1, 1, 1. I don't love those. So sure, I'm just gonna remove the ones. 1 doesn't feel right. 1 meter doesn't feel great. Ooh, somebody points out that Robusta is grown at 0. Is that the case here? That our species? No, those aren't Robusta. What if I said species equals Robusta? Those seem to be grown at a variety, so I'm not quite seeing that. I like removing the ones. I don't feel great about having some extreme values there. These extreme values, these are higher than 3,000, who knows. Could also clip them. Whatever, in any case, we do see a positive correlation. I'm guessing, eyeballing here, this looks statistically significant, but let's actually check statistically significant within each of these groups. So, I grouped by and summarized the correlation. Having correlation is really nice. It's quantitative. I'm also going to create a model. I'm going to do a summarize, create a list with a single LM. This is a way that I can summarize a model object, get out value explained by altitude mean meters. Notice now I have a list column with the model. I can apply Groom's tidy function to that. For each model, apply Groom's tidy. And I can unnest the tidied model. And now what I have is a statistical model for each of these in terms of, that has a slope, that will say intercept and slope for every one. I'm not that interested in the slope here, I'm interested in term is altitude mean meters. So here's my many models approach. I'm also interested in a confidence interval for each of these. So I'll pass tidy conf int equals true. Here we go. And now I have a plot that I might be interested in, which is look at the not the correlation, the slope. Yeah, okay, the slope is going to be the estimate. Let's see. I'm actually going to do altitude mean meters over 1,000 to make this out of kilometers. Oop. It doesn't like the out of 1,000. Oh, yeah, okay. I'm going to do mutate km equals this. I'm going to rewrite this little. Yeah, I can't quite do that. I could have. There's a workaround. The workaround doesn't matter. Equals km. I just wanted these estimates to be on a reasonable scale. So then what I do is I say, all right, I have my estimate. I do it by metric. I do mutate metric equals FCP reorder metric. It's not called metric anymore, it's called term. Nope, that's not true, it's not term. It's still called metric. Oh yeah, metric by estimate. And here we have our estimates, but even better, I can add error bar h. X min is conf low. X max is conf high. And let's see. I'm going to make it a little shorter. Here we go. And just like that, what we have is valuation. Each 1,000, each kilometer altitude contributes this much. All right, so what this does is get across like, okay, there might be slightly different correlations, but they all very much overlap in their confidence bound. Even clean cup, which is a little bit lower than the others, is mostly just a lot wider. I don't have a good explanation for that. Maybe clean cup, yeah, maybe the variation in clean cup was a little higher. I don't remember checking that. But of course, but clean cup, I was going to say like, yeah, body overlaps, but it's pretty unambiguous that sweetness is close to uncorrelated with altitude and much lower than these others. So this was an application of multiple models. We'll say it's 95% confidence. So it's going to get us some information in terms of like the effective ratio of altitude and score. Last thing I'm going to note here. So actually, I see one question I think is really interesting. I looked around this and I was looking at estimate. I wasn't looking at p-value. Why wasn't I looking at p-value? Because p-value really pops up here in terms of what overlaps 0. I can tell you just from looking at this, these p-values are all significant at least less than 0.05. These are greater than 0.05. These are a little below 0.05. This is probably very high for a p-value. And yeah, this is like a breakdown of each of the models. So in this case, I'm not interested in the p-value because I'm kind of interested in comparing these estimates, and it's the size of the estimates I care about, not just do they overlap 0. As it is, I suspect that clean cup and uniformity, even though they technically overlap 0, the fact that most of these metrics are correlated with altitude makes me suggest that maybe these are 2, or maybe they're not, and they're just clean cup. How could that be? How could that be associated with altitude? Maybe it just is kind of gets across from all the others. That's actually a little interesting thing is maybe people are maybe if there's no reason that whether the cup is clean will be associated with altitude, then the fact that it slightly is might be an indication that people are letting their opinions of the other good ones kind of affect this. But yeah, all right. So this is me looking at somebody said, oh, I like this idea somebody Victor had, which is color with p-value less than 0.05. Yeah, I think it's a pretty good approach if you do want to use significance. You could also correct the p-values. I don't think it's going to make a difference in this case. All of these are, I'm pretty confident all of these will be very significant, and none of these will. All right. So to wrap up, what did we do today? We did a little exploration of our coffee lumpings. We looked a little by country. I didn't actually look at how country. I didn't statistically look at how country or company relate to quality, but I did. Then I did some pivot longer to really look across our types of metrics. Here we go. And we get to see, oh, there's kind of two types here, two ways that these are evaluated on the sheet, and they end up clustered differently, which we're able to confirm by creating a network diagram and really understand what the two types of metrics are here. Finally, we looked at association between altitude and each of these metrics, as well as with overall quality, while doing a little cleaning up along the way. Yeah, what would you say your favorite plot was today? I'd say my favorite plot, I do like the joy plot. So that might be one I stick with. Okay, that wraps up the my analysis on coffee ratings. So now I'll actually do today is to add the coffee ratings. Make this available right away. If you're following along, go ahead to the Data Screencast GitHub repository, and you'll be able to see the code that I just wrote. All right. Thanks, everyone, for joining. I hope you had fun. I certainly did. If you enjoyed this screencast, please don't forget to subscribe and follow me on Twitter, where I tweet @drob. Thanks so much for joining. I'll see you next week.